Hello, everyone. It's time for section 4.11, the central limit theorem class prep. All right, this is an important topic. We're heading into our statistics segment of the course, and that's, we've been, calculating things in spreadsheets, and I wanted to get you to start thinking about data. And really, remember, the goal of this kind of statistics is to draw conclusions about a population based on a subset of the population, right? We only have part of the population, and we want to talk about the entire population, all right? So this idea, this theorem that we're going to study really helps us, like, given a random sample here in the middle, how do some of those statistics behave? Like, if we're just calculating like a mean or a standard deviation from a sample, we need to understand those things really well. If we know that, we're going to know how well our statistics represent the population. All right, this is the foundational theorem in all statistics. All right, so anybody that studies statistics understands this theorem really, really well. To keep it simple with this section, we're just going to study the central limit theorem in these two different forms. All right, so we're going to study the central limit theorem and how it applies to X bar, the sample mean, and how it applies to the sum of observations. All right, so really, this is the reading of the theorem. It says, let x1 through xn be a random sample from a population with a certain mean and variance. This is one thing I want you to notice. This is just a population. We don't know what kind of population it is, all right? Like, it's just a population. We do not know, whoops, I'm trying to draw. We do not know if it's a normal population or we don't know anything about it. All right, so it just is a population, okay? So we're assuming it has a mean and variance. Maybe it's an unknown mean and variance, but it has a mean and variance. All right, so we're concentrating on how does X bar act and how does the sum of the sample observations act. And what we know is that this theorem says that the sample mean will be normal. Even if the population isn't normal, the sample mean will be normal. It'll have this mean and this variance. And this sample sum, if you add them all up, it'll also be normal. It'll have this mean and this variance, okay, approximately. All right, so it's a really powerful thing to know. For most populations, if the sample size is greater than 30, this central limit theorem approximation is actually a really good approximation. That's why in class, I think I told you, like, a sample size of bigger than 30 is usually considered large. It's because this applies then. All right, let's look at an example. All right, so suppose the checkout time for a customer in some store has mean 3 minutes and standard deviation 2 minutes. Okay, so once again, this is sort of like related to queuing theory, right? Things waiting around kind of problem. All right, what is the probability that the total time spent by a random group of 50 customers, what's the probability that that's less than 3 hours? Okay, so maybe like, I'm going to probably have this number of customers. What's the probability that that's going to take like 3 hours or less? All right, so the first question is this a sample sum or is it a sample mean, average? Hopefully you picked out that it's the total time, that's a sample sum, that's that S. All right, so hopefully you wrote down how S is distributed. What we know about S is S, they use a subscript of N, I'm just going to write S. S is distributed as normal with the mean N times mu and variance N times the original variance. Sorry. All right, so the mean should be, N is 50, right? 50 times 3, this should be 150. And the variance should be 50 times 2 squared, right? Because this is standard deviation. 50 times 2 squared, 200. All right, so that's how this is distributed. Okay, that means I'm going to draw like a picture, and I'll probably have to clear the picture and then come back because I'm going to run out of room when I'm writing with a stylus. That means this sum, S's picture, okay, the way the total time spent by 50 customers looks is the mean is 150 because it's normal. All right, and the standard deviation is the square root of 200. So the standard deviation for S, let me write it this way. Standard deviation for S will be the square root of 200, which is like 14.1-ish. All right, so this is what it looks like. You know, we have about 3 standard deviations on each side, right? And it's normal. So, you know, the standard, this is 150, and then if we're going by 14s, right, this is like 164 something, right, and this is 178 something, right? So you can kind of start to understand what's going on here. All right, so what I'm going to do is I'm going to clear some of this, and I'll come back with this picture drawn a little better, okay? And we want to find the probability that these people spend less than 3 hours. All right, so this is kind of how our picture looked, right? Sorry, my little hashed marks are not equally spaced, but we know 3 hours is 180 minutes. On here, we had 154, 164 point something, 178 point something. 180 is just a little bit bigger than that 178. And we want to know what's the probability the total time is less than 3 hours. So that's this area. Right, so what we're using is we're using S's picture because the question is about S, and we know S is normally distributed. So now, if we're going to use our normal table to get this, we need to find the z-value. So we know that the z-value for 150 will be 0, right? So now this is like our S-axis, and this is our z-axis for our standard normal, and we need to figure out what the z-value for 180 is. All right, so when we standardize, I'm going to let you find this probability, by the way, but when we standardize this, we're going to have z, right, equals the score that you're interested minus its mean. So now it's like the S minus the mean for S, right, over the standard deviation for S, right? So you always have to make sure the mean and the standard deviation go with the right distribution, right? You don't just go randomly pick a mean. You have to make sure it's the right mean. Okay, so this is 180 minus, okay, go find the right mean and the right standard deviation and find that z-value. So fill in that blank, and then I want you to find this area. So in the end, I want you to find the probability that of that shaded area. So I want you to, in your prep work, do those, fill in those 2 blanks. What's the z? And then you'll fill in, that'll go here, right? And now you'll look it up in the table in the front. Hopefully you can find that area. Hopefully you know how to do that. Okay, similarly, we can ask other kinds of questions that are related to a normal distribution, all right? So like we can ask, find the 30th percentile for the total time taken by 50 customers, all right? So that would be the time, so that like 30% of the time it's shorter than that, but 70% of the time it's more than that, and that would be this spot right here, right? So here's our 150 in the middle on average. We want to know this value down here. Where this, I don't know why that little square is showing up, is 0.3, right, and the area above it is 0.7. All right, so what you do, right, you have to go through the standard normal distribution, right? You have to figure out for standard normal what is the 30th percentile first. If you look up 0.3, I think you don't get 0.3 exactly, you get 0.3015, I think is the closest thing you can find. Notice it should be a negative number. It ends up being negative 0.52 is the z value. All right, so once again, I'm going to have you go and figure out what this 30th percentile for S was, but you can get it by, Z equals the score minus the mean, right? The mean for that score over the standard deviation, right? And the Z we know is negative 0.52, right? So that means negative 0.52 is equal to this score that we're interested in, S minus the mean. I'm going to make you go figure out what standard deviation you get, right? What goes there? What standard deviation should we use? And calculate this S. All right, so I want to know what is the 30th percentile. What is this value? It should be a little less than 150, right? Okay, so go try that